Hello, good morning. My name is Bartosz Jabłoński and I'm Head of Development in PGS Software. I'm pleased to be with you today on this conference so that I can share with you some of the ideas and concepts around computer vision in manufacturing. Before we get to that, let me share a couple of thoughts around the industry. Because when I was preparing for this conference, obviously I've read all the challenges you shared on the platform. And you know what? The common denominator is smart manufacturing. And this is very much in line with the state of the industry. Actually, research shows that vast majority of companies are already pursuing or planning to pursue some kind of smart manufacturing strategy. At the end of the day, what are we looking for? What are we hoping for? We're hoping to find some bit of a gain, something which would give us a bit of competitive advantage, something which would make us a bit more flexible, a bit more scalable, something which would help us to increase our throughput or decrease our costs. So we are looking for different solutions or technologies which we hope could help us with that. But things have changed overnight. What we thought was like a 5-year strategy actually must have changed. COVID hit us all. What we hear from our customers is that right now all investments are under very in-depth scrutiny of CFOs and boards. At the same time, the environment changed in the other direction. The level of demand predictability is quite low. Some companies, some customers say that it's like a Black Friday every day, but you don't know which day it would start. And the whole dynamics of the supply chain changes as well. It's not only to replenish stores in retail and commerce, but also to get out the orders of the warehouse on time, without warning. Customers are expecting high levels of customization. At the same time, the industry observes increasing shortage on labor. I've heard on the other conference that we are all looking for the automation which would actually change humans into superhumans so that we can respond to this situation. So majority of companies are already pursuing some kind of smart manufacturing strategy. But you know what? There are challenges, obviously, and these may be different types of challenges. Costs, buying, lack of internal talent or skills, you name it. What I found recently in the other report, is that one of the most important challenges these days, and we hear from our customers as well, is the overabundance of technologies. It's not the lack of technological solutions, it's not a lack of the access to those technologies. It's overabundance, which means that the challenge is to find the right mix of technologies so that it would be a good investment for you to pursue with smart manufacturing solution. So let's take a look at a very fresh Gartner report on technology trends in manufacturing operations. These comprise of two groups. One is connected worker and the other is smart factory. And you know what? It's not like one single technology trend. It's a mixture of different things happening right now, which would actually get very much in line into those trends. And we won't go through all of them, but I guess I want to focus on a couple which would be very much in line with computer vision application we are going to share with you. These are hyper-automation, the set of solutions, often ML and AI algorithms, which help us to automate some decisions or even the whole process. This is multi-experience, how workers are experiencing the environment, how they can interact with the environment, and a whole set of new touch points they're having while working in a factory. And autonomous things. This is the third very important trend which we are all observing and which we will cover later as a case study. That relates to another research, which shows that already 64% of companies are right now planning to implement or started the implementation of different types of smart robots in their factories. When we take a look at the statistics of the actual productionized version of AI and ML algorithm, it's still pretty low. Automotive stands out of it, but the overall adoption is still something which will come. But I believe it will come very quickly. Computer vision is one of those fast-growing set of underlying technologies which supports the development of these trends. Let me give you a quick review on the current state of the art of these methods. State of computer vision even 2-3 years back was not great. Algorithms were able to produce only very rough classification tasks. You can see on this example other cars, roads, trees. They were classified, but signs are missing. Results were often inaccurate and leading to false positives or false negatives. If we get even a couple months forward, it gets more precise, but still limited on the level of details. Here you can see results from a year ago. If you take a look at the more recent applications, you can see solutions which were able to track people or animals. These had pretty accurate position and the state on the scene. Going forward for today's situation, stereoscopic vision is coming a lot into play, with the capability to model the 3D scene and measure size and depth of the objects. On the right hand side of this picture, you can see motion tracking with appropriate vectors identified, which can actually extrapolate how the person or car is going to move in the next seconds. This very quick evolution creates endless use cases and possibilities within manufacturing industry. Starting from the very simple use of industry camera. You can see an operator and a hot saw in the middle of this room. Right? So you can provide some kind of a warning for the operator. It's hot, be careful. Going to a more complex example, where you can see a defect detected on a bottle. It's pretty easy on a static image, but gets challenging at a high speed. Even more complex solutions provide visual inspection of big components and parts of cars, but also very small components such as electronic pieces. You can use it both for inspections to remove faulty elements, but also treat those sample measurements as an input for more complex statistical process control systems. Thermal camera and thermal imaging get a lot more data. You can use it to perform predictive maintenance and to detect any kind of failure that is going to happen in the future. And it can go even more up to proper monitoring of very complex pieces of equipment and getting data from sensors on top of the camera stream. Further applications let you steer the whole environment, detect people and parts connected with SAP or any other kind of internal systems that is tracking your parts and goods in a warehouse. So let me share with you a couple of practical implementations of computer vision for manufacturing industry we had a chance to work with recently. Computer vision based HGV was developed for a company called Vobit, which produces industrial grade HGVs. The goal was to develop an autonomous robot which follows the operator while he performs his tasks on the factory floor or in a warehouse. It is based on a set of technologies including deep lens, NVIDIA Jetson for edge computing, and 5G for efficient communication. This concept has further extension into full-scale order monitoring system with outdoor 5G-based tracking and control. Let my colleague Adam Grugel share with you a bit more story and details around this fascinating project.
We recently developed a solution which integrates an AGV which is able to carry up to 1800 kilograms with a stereo vision camera and very modern technology based on deep learning which is able to follow the operator in the warehouse and not crash into any obstacles. This way he can focus on searching and picking the packages or any pieces of equipment he needs to collect and place them directly in the basket. The basket is equipped with RFID-based solution which immediately notices what kind of package was packed. When the operator approaches the robot, he introduces himself saying, "Hi, follow me." And then we use computer vision to authenticate the operator based on his face. When we get the authentication, we start following him. To trace the operator, we use stereo vision camera, so two lenses combined together. The distance between lenses is constant, and this way we are able to calculate the distance between the camera and the operator. We developed our custom tracking algorithm for tracking the operator, and the algorithm is occlusion agnostic, so when someone passes between us and the robot, it doesn't impact the robot performance. The robot doesn't lose the operator and keeps following him. The robot is also equipped with a LiDAR, which makes sure that we don't crash into any of the obstacles. Our software runs on deep lens and constantly tries to understand what people speak around. It uses AWS Transcribe to convert speech to text, and once it identifies a phrase, "Hi, follow me," it takes a picture of the operator. Based on the operator's face, AWS Recognition tries to match the face with one of the faces which are uploaded to the collection of the operators. Once it matches the face with one of the faces in our collection, it sends the information to the robot that he should follow the operator. We also developed a really nice modern solution which allows you to trace all the robots on a screen, where someone in the traffic control at your facilities can constantly monitor real-time where all the robots are and what they have in their baskets. Our product can also serve as a personal shopping assistant while shopping in a shopping mall. Oh wait, there is a shopping mall down there, let's go and see. Follow me. The robot is able to accelerate, decelerate and turn, so wherever the operator moves, the robot follows him.
So that was a brilliant piece of technology combined with a practical AGV-based use case. As you can see, it combines machine learning-based hyper-automation, new set of experience for the worker with autonomous thing like AGV on steroids. Machine learning use cases go further than that. We are currently working with a company called Baloth on another fantastic project based on mesh network of infrared cameras. Cameras are located around an industry pipeline in order to recreate in real time 3D model of the monitored facility with the capability to monitor temperature from all different angles. Alright, so these are the key takeaways. We all see the increasing number of technical solutions available on the market, and I guess it's crucial for all of us to find those which can help you to reach your goals within your digital transformation journey and be aligned with your strategy. Computer vision is one of them which we had a chance to work with and which we had a chance to implement for our customers. I wish you to succeed with your digital transformation journey. And now I'll be happy to answer all your questions during the following Q&A sessions. Thank you very much.